So we will cover what a native app is, and I'll also talk about other app technologies, and then tips for being the PM on a mobile app project, some of which I think will be relevant to other development projects, and then a wrap-up. But first, why was I interested in talking about this? So a little while ago, Vigit built a native Android app for a company called Fiscal Note. They're DC-based, and they use AI for analysis of governmental legislation. It was expensive, took a long time, and I learned a lot. Ever since then, I've been fascinated with this kind of development. So what is a native app? Well, to learn what it is, it's best to start with what it is not. So there are two other types that fall under this sort of general app technology that you should know if you're interested in this or you work in this space. The first is a hybrid app. So hybrid apps are built for multiple operating systems like Android, Google, Windows Phone, etc. They can utilize device features, but it's not easy or intuitive to build for those. Some popular recent frameworks have significantly leveled up hybrid apps. So one called Ionic for MarketWatch here, and then most prominently React Native, which is a framework built by Facebook, used for Skype, a bunch of other companies, as well as Facebook itself. And then the next one is a web app. So this is slightly different from just a website. A web app has interactivity and functionality, so it still utilizes a browser and can still be written with languages like HTML, CSS, and JavaScript, whereas a normal website could be just purely content. So Google Docs, CodePen, and Trello are some examples of this. So now, as promised, what is a native app? Most importantly, they're built for a single operating system. They can seamlessly incorporate device features like the camera, GPS, microphone, Touch ID, and they use specialized languages like Swift or Kotlin, if you've heard of those. And then they have frameworks specific to platforms, so one for Android and one for Apple. And the most important thing to take away here is that they're built for a specific platform and take advantage of all that has to offer. You'll notice that these are not just specific to Android or to Apple or anything like that. In those cases, there are multiple native apps for each. So there is a native app for Uber for Apple and a native app for Uber for Android. That's an important distinction to keep in mind, and I'll touch upon it in a little bit. So some pros and cons to note as we move on. This is a little granular, but I promise it's important, so bear with me. Performance. When you swipe or tap on an app, you expect it to react right away. This is easier to code, and so it's more prevalent in native apps. They're also just much faster, pure and simple. The tooling is great. So I mentioned two first-party tools, Xcode and Android Studio for Apple and for Android. They provide developers with design previews, accessibility checks, and performance monitoring already built in. Security, certainly important nowadays. So for native, everything can be coded into the infrastructure of the app and encrypted, whereas a hybrid app is essentially a browser, so it exposes features of the underlying platform. System UI is the last one here. Native allows devs to match the app UX and UI to the platform conventions. So since Android and iOS users are pretty loyal to their devices, even subtle differences can cause users to stumble. And then the not so fun parts, cost is the first one, the biggest one. So a lot of the time developers only specialize in one operating system. Building natively for multiple platforms requires more resources. Timeline, hand in hand with this. There's a lot of technical expertise needed to build a native app. It can be hard to find devs that are good enough for this, not including the time it takes them to actually code it up. There's a distributed code base. So like I mentioned earlier, native apps built for iOS won't work for Android. Native apps built for Android won't work for iOS. Same concept with Windows phones. So you have two or more code bases to maintain. So that's why the apps aren't as flexible. And the last one here, maintenance. Native devs also have to account for variabilities in device and components, which is known as device fragmentation, as well as older versions of operating systems. But I am not here to sell you on app work, although it's a good idea. On the contrary, as I was preparing for this, I realized that it made the most sense to focus these tips on kind of a general mobile bucket for native and for hybrid. Generally, there's a lot of overlap for our part of this work. So it's best to think of this, again, as more of a mobile versus desktop and not a native versus hybrid versus web app thing. So what do you need to know, and how should you PM a mobile build? I can't cover everything. Certainly wouldn't know how if I wanted to. So instead, the tips I'm about to give hopefully should make this a little more fun and exciting, learning experience, and a professional development opportunity if you're ever in this situation. Tip 1 is to learn. Everything I just said, you should try to understand at the beginning of a project like this. No matter what sort of mobile product or platform you're on, you should learn about the tooling, the platform themselves, and the constraints. They'll all help you speak on a level playing field with the makers on your team, and that'll facilitate decisions you need to make as a project manager. You'll learn what your developers are facing to, so some more technical things to keep in mind. Apps use languages that are different from more common ones, but they provide features to help write higher quality software. And then a browser is more forgiving, so an error in an app can crash the app, so the cost of failure is very high. And then some mobile apps are written in statically typed languages, which require a more formal way of expressing ideas. That helps mitigate bugs, but it makes edge cases painfully clear. So code written in Kotlin, which is an Android language, you're going to be required to think through like 90% of a problem, whereas you can get away with 30 to 40% in a JavaScript project. And then integrating with an API can be especially difficult for mobile tech. So finding solutions for that doesn't usually call upon your developers to write better code, but to write code in a very specific way that may not be intuitive. Tip 2 is to articulate the mobile UX and design constraints. So the web has fewer constraints than mobile. So you can think about designers and developers are working with standard conventions on desktop as opposed to protocols. But for mobile, material design, systematic controls, and expected user flow dictate a lot of how you need to build and use an app. So for example, what do the system buttons on your device do within the app? What happens when the user is offline? Can the app access device features like the camera or the microphone? And then user error is also much more prominent, specifically for forms or typing or things like that, because the hitboxes are smaller. Tip 3, don't count on designs being approved by your client. They just look and feel differently when they're in your hand. It's that simple. Muscle memory and years of navigating through apps have taught us to act and feel a certain way, and so unexpected behavior is really magnified. So in my experience, you can get about 90% of the way there, and then working to get approval on the last 10% leads to a disproportionate amount of back and forth and often doesn't result in any real decision. So everyone is kind of spinning their wheels. And that's where you and the client should both understand that it's impossible to exactly define how something is going to work in a static comp, and you need to move towards a prototype. So in a weird way, these static designs, again, are never 100% approved, which makes me very nervous. I'm sure it makes some of you very nervous, but it's okay, I promise. Maybe. Tip 4 is to set up continuous integration as soon as possible. So this automates the building process through testing code every time something is deployed to a new version. It allows team members who are working on an app to do so in isolation, like developers like to do, without any issues. So because when mobile developers are working at the same time and their different sets of code get pieced together on an irregular schedule, errors can occur. Continuous integration cuts down a lot on this, and the QA your team has to do, and the communication that you have to facilitate. Last tip, if your team is responsible for launching, you as a PM can spearhead the app or Play Store submission process. It's a complicated thing. Apple and Google both disperse information across a shocking number of disconnected pages. Sorry, Philip. A couple examples of the types of things you need to be aware of. So screenshots, Apple will reject your screenshots if they are placed within an incorrect device frame. So if you have a 5.5-inch screenshot that has the iPhone X notch on it, it'll get rejected. If you have a 6.5-inch screenshot that goes within an iPhone 6 frame, that'll also get rejected. URLs, you'll need to provide a privacy policy, marketing, and support URL, some of which you may not even have. And then App Store optimization, that's a real thing. Think of it like SEO for the App Store. So an example is you have keyword fields. Each keyword field has a 100-character limit. Commas count towards a character limit, but spaces do not. So there's some pretty obscure and picky things. But the bottom line is, if you can take this on, you'll be taking work off of your developers' plate so they can focus on writing code and hopefully get to more features. So despite everything I just said, I think this is really fun. The app landscape is evolving at a much faster pace than web. Mobile traffic is higher than it is on desktop. We probably all know that. And then it's a challenge. So as we all know, as PMs, our lives are all about being handed lots and lots and lots of challenges and then learning to overcome them. And the only way to actually survive that is to try to make it fun. That's all I have. Thank you.